When wiring a detached workshop, understanding the National Electrical Code or NEC requirements for grounding is crucial. The inspector's requirement for a ground rod likely stems from section 250.50 of the NEC, which addresses the grounding electrode system. This section prioritizes different types of grounding electrodes, and the ground rod typically becomes necessary when preferred options are not available. Section 250.50 focuses on metallic water piping systems. If a metallic water piping system extends throughout the building, meaning both the house and the detached workshop, it should be used as the grounding electrode system. This is because metallic water pipes, being in direct contact with the earth over a considerable distance, provide an effective path to ground. Section 250.50b addresses the metal frame of the building. If the metal frame of the building or structure serves as the grounding electrode as permitted in 250.52 A1, it should be used as the grounding electrode system. This applies if the workshop structure incorporates a substantial metal frame that is effectively grounded. In the absence of a metallic water piping system or a suitable metal building frame, section 250.50c comes into play, dealing with ground rods or pipes. This section stipulates that if neither of the above options is available, a ground rod or pipe must be driven, where practicable, at least 8 feet into the earth and must be used as the grounding electrode system. This is why the inspector is likely requiring the ground rod. It's a common and reliable method for establishing a ground connection when other, more substantial grounding electrodes aren't present. Section 250.56 provides additional information on the grounding electrode conductor. Section 250.56 specifies the minimum size for the grounding electrode conductor, which is the wire that connects the ground rod to the grounding bar within the workshop's electrical panel. The code mandates that the grounding electrode conductor should not be less than 8 American wire gauge copper, or not less than 6 American wire gauge aluminum or copper-clad aluminum. This ensures the conductor has sufficient ampacity to safely carry fault current to ground. Section 250.66 elaborates on the grounding electrode system for separately derived systems. Where a separately derived system is installed, a grounding electrode system must be provided as specified in 250.50. Since the workshop has a separate panel from the main house panel, it is considered a separately derived system, thus necessitating its own grounding electrode system, as defined earlier. To summarize the grounding hierarchy, firstly, a metallic water piping system, if present, should be used. Secondly, a metal frame of the building, if adequately grounded, can serve as the grounding electrode. Thirdly, and only when the first two are not available, a ground rod or pipe must be installed. Grounding serves several vital purposes. Firstly, it provides a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protection devices like circuit breakers or fuses. This helps to quickly clear faults and prevent electrical shock hazards. Secondly, grounding helps to stabilize voltage to ground during normal operation. This reduces voltage stress on insulation and minimizes the risk of equipment damage. Thirdly, grounding provides a reference point for electrical systems, minimizing electrical noise and interference. This is particularly important for sensitive electronic equipment. When installing a ground rod, ensure it is driven at least 8 feet into the earth, where practicable. The top of the ground rod should be flush with or below ground level. Use a listed ground clamp to connect the grounding electrode conductor to the ground rod. Ensure the connection is tight and corrosion resistant. The grounding electrode conductor should be run in a straight line, without any sharp bends or splices, from the ground rod to the grounding bar in the workshop's panel. Securely fasten the grounding electrode conductor to the wall or other support structures. Use appropriate connectors to terminate the grounding electrode conductor at the grounding bar. Tighten all connections securely. It is also important to separate the neutral and ground conductors in the subpanel. The neutral conductor carries normal load current, while the ground conductor provides a path for fault current. Mixing these conductors can create undesirable circulating currents and increase the risk of electrical shock. Connect the neutral conductor to the neutral bar in the subpole and connect the ground conductor to the ground bar. Ensure these bars are electrically isolated from each other. Remember that electrical codes and regulations can vary by location. Always consult with the local authority having jurisdiction or OJ for specific requirements in your area. The AHJ has the final say in interpreting and enforcing the NEC and may have additional requirements based on local conditions or amendments to the code. Obtaining necessary permits and inspections is crucial to ensure compliance and safety. The inspector's role is to verify that the electrical installation meets the minimum safety standards outlined in the NEC and local codes. Their guidance is invaluable in ensuring a safe and reliable electrical system for your detached workshop. By understanding the NEC requirements for grounding and consulting with the local AHJ, you can ensure a safe and compliant electrical installation for your detached workshop. If you are unsure about any aspect of the electrical work, it is always best to consult with a qualified electrician. They can provide expert guidance and ensure that the work is done safely and correctly. Safety should always be the top priority when working with electricity.